now it's time for the last but not least invited talk of this conference. So it's a big honor to introduce you Dr. Jiří Šilha, my dear colleague and a friend. Dr. Šilha got his PhD here at our university more than a decade ago, and then he moved to Switzerland, to University of Bern, where he spent 4 years as a researcher. Then he moved back to our Communist University, to this faculty, and he started a brand new research group focused on space debris research, and he has been a principal investigator of this research group ever since. Dr. Šilha has an extensive collaboration with European Space Agency, and he is also a founder and a CEO of Astros Solutions, a spin-off company which focuses on the space debris as well. So without further ado, Dr. Jiří Šilha, stage is yours.
Thank you, gentlemen, for the kind introduction. So good afternoon, everybody. As was already told, I am the researcher, but I'm also a CEO of a company. And today I would like to introduce you or give you an overview how actually research and industry can collaborate together, how it's done, and what are the details behind to actually make it work. Before I will start to jump directly to the topic, I would like to introduce some of the basic terms I will be addressing today. So first, we need to understand that astronomy, but also the business, let's say, what we'll be talking about today, is strongly related to space ecosystem. Basically, space ecosystem in European landscape means European Space Agency, ESA. European Space Agency is basically an international entity which is not directly attached to European Union nor European Commission. Even European Union can hire European Space Agency to perform some of the research and development tasks. It is an institution which has 22 member states and 4 associate members. And it focuses on several different aspects, mostly related to technology development. And on the right-hand side, you can see actually that there are several different topics which are covered by European Space Agency. We have their technology, engineering, and quality. We have science, which is only a small fraction of the whole European Space Agency focus. Then we have human and robotic exploration, which is actually supporting the manned flights and taking care of making people safe in space. Connectivity and secure communication, Earth observation programs. Then we have a navigation, like Galileo, for example. Operations, under which is so-called S2P program. This is a space safety program I will be actually referring to and today hold presentation. And then we have a space transportation and commercialization industry and competitiveness. So these are the different aspects. Each of them has a different technical experts which are actually taking care of that the technology is progressing in that area. So we belong under the program of space safety, or S2P, and space safety basically means that you can imagine that currently we are using space technology in quite extensive level. In total, so far we got more than 108 billion people on planet, and only several percent of it is actually using space technologies today. But we should expect from today and forward that everybody who will be born will be to a certain level use space technologies. That means that the economy, which is now in space roughly 630 billion, will increase quite a lot, and that we expect in 2035 to be on the level of almost $2 trillion. This means that we will build the infrastructure on orbit, the rockets are getting cheaper, the spacecrafts are getting cheaper, and space is accessible to more and more countries. So the whole space ecosystem, all the technologies related to it are also increasing, and with it comes also a hazard. The hazard comes from the environment when we are operating satellites or when the people are flying. That means this hazard is actually threatening the infrastructure on orbit and is threatening also people on the ground. That's why ESA and other agencies also around the world created segments which are called space safety or related to space safety to actually keep eye on these old threats we have from space and try to find some conclusions or solutions how to avoid them. From space, the whole space safety segment in a European Space Agency landscape can be split into 3 segments. First one is protection of satellites and humans against space debris population, which are non-active satellites and other objects on orbit. Then there is a protection against collisions or threats from meteoroids and asteroids, nerd asteroids, which are natural objects. And then protection against negative effects from solar activity, which is covered by the so-called space weather segment. And now I will go even deeper in the space safety segment, and I will be talking about space debris, just to give you some technical description of this population. Basically, space debris is everything which was created by human activity and is on orbit, and is orbiting the Earth on geocentric orbit, and we don't have anymore any purpose for this type of objects. First, the biggest group, or one of the most massive objects, are non-operational defunct satellites. Satellites which we either decommissioned, we are not using them anymore because they are old, or the fuel ran out, or these can be satellites we just lost contact with, and they just rotate or are staying on the orbit. We don't want them to be there, but they are actually threatening the other functional satellites. Other massive objects which we have on orbit, hundreds of pieces, are upper stages from rockets. Rockets are helping us to bring people and the technology on orbit and into the solar system. On the right-hand side, you can see Ariane 6, which was launched recently, is the first launch of this type of rocket, which is a European rocket. And on the bottom, you can see upper stage from a Japanese rocket, H2A, which is actually a real image of this rocket, which is now being investigated by another satellite which is orbiting this rocket and analyzing its attitude. This will be the future demonstration target for future demonstration of active debris removal to stabilize the space around Earth. But most abundant population on orbit are fragments. When these big, massive satellites and upper stages, which some of them are larger even than this room and have several tons, are exploding, fragmenting. This can happen with collision with another object, or it can happen because there is some malfunctioning on board and there is an explosion of the fuel tank or batteries, for example. In that case, hundreds or thousands of fragments which are big, like 10 centimeters, are actually orbiting the Earth and are threatening the population which is already on orbit. These objects are very heterogeneous. They can be symmetrical, but usually are asymmetrical, and different chemical composition. You can see on the top different type of materials we are using for satellites, which might be created and staying in orbit. With space debris, strongly related topic of re-entries. Re-entry, as it suggests the name, is that the objects, the massive ones, the small ones, are eventually re-entering the atmosphere because they are in interaction with atmosphere particles, which usually cause them to lower their orbits in certain time, and they then in very high velocities enter the atmosphere. Usually they start to ablate, so the temperature is very high, similar effect we see with meteors. And then these objects fragment. Sometimes the fragments demise, so nothing is left, only some chemical particles which are in the atmosphere. But sometimes big pieces can survive and actually reach the ground and threaten the population and, let's say, buildings, infrastructure we have on ground. On the top, you see an animation from one system, all sky systems we are using, observing Chinese upper stage, which was on lowered orbit and re-enter above Hawaii roughly 3 years ago, and we observe it from 2 different perspectives, and now we're doing the modeling of this event. So you might be thinking, okay, but I never seen anybody being harmed by an artificial object falling from the sky. But this might actually change soon. I will just demonstrate 2 cases from this year. On the left-hand side, you can see a piece which is, I will try to point, which you see here. This is a piece which went through this building. It's a house in Florida. It happened in April 2024. It went through the roof down to the basement, so it went through the whole house. Nobody was harmed, but it happened during the day, and the son of the owner was actually one room next to this event. And NASA was investigating this object and find out that it was part of a pallet. You can see here up on the top. This pallet in 2021 was detached from International Space Station. It contained old batteries, which were replaced already on ISS. And this pallet was supposed to burn out in the atmosphere. But something went wrong with the calculations, and some of the pieces actually reached the ground. Another case from this year is a part of the Dragon crew manned flight when the crew was coming back. Usually the Crew Dragon has two pieces. One is the crew cabin where the people can actually survive, and then you have a trunk which usually has a support mechanisms on board. This trunk is usually released before re-entry and burns out in the atmosphere. What happened in May is that part of this trunk actually reached the ground and fall in the North Carolina in the national park. So this was only 1 month apart, those two events. So for services which are related to space debris, there are several, or the artificial population or orbit, but the most crucial one is conjunction analysis. This graphic is roughly showing the high level how it is done. Basically, what you want to do is that you want to support every operator which has a satellite on orbit, and you want to secure that these satellites are not colliding with space debris. These are moving very fast, both of these type populations. But so what you can do, you have several segments which are feeding this service. You have people on the ground or on orbit who observe the space debris, gather the data about the positions of the space debris at that specific moment. You send it to another expert, astrodynamics. They calculate the orbits from this data. And then from these orbits, you do predictions to, let's say, a few hours, few days in the future. Then other experts do conjunction analysis when they statistically try to estimate what is the probability of collision between your satellite or any satellite on orbit and the fragment. If the probability reaches a certain level, the operator is informed and needs to move the satellite to a different orbit to avoid the debris, because we cannot move the debris object. This whole infrastructure has different experts and different, let's say, industry involved to make sure that this is a good running mechanism. And what I will be addressing today is mostly focusing on this type of services. All right, so now I would like to move to the definition of collaboration and research and development definitions. Probably everybody is aware of it, but I just want to make sure that we are on the same page. So we can split what we're all doing to 4 big, let's say, subjects. One is that we do basic research. With basic research, we try to understand the basic principles which are in the universe surrounding us. We try to use the mathematics and physics to describe these basic principles. So usually research institutions, universities are focusing on this type of activities. Then we have applied research, which is focusing how we can actually use the knowledge we have about the nature around us and use it to somehow benefit us, right, directly. So probably to create some kind of product which will make the people's life safer, longer, and more comfortable. Then we have a development which is necessary. Once I have a concept, okay, what I would like to reach, which knowledge, I need to put it together. So there I need to do development. And once I develop something, I need to actually go to sell it. So I have to create services and products which I then sell. So the reason I'm mentioning these 4 aspects is that universities and research institutions are usually on the left-hand side of this chart. So we are focusing on basic research, applied research, and we sometimes do development. Some of us are getting actually sometimes very tired of doing development, because development is a lot of management. It's not that creative like the research itself. So sometimes industry is taking over some of these aspects, and most of the focus of the industry is selling services and products. But sometimes they have to develop by themselves their own services and products, so they are doing that. And sometimes, to very limited level, they can be also involved in applied research. They can support it directly with some funding, let's say, or they can do it by themselves, but it's very unique. So the overlap between those 2 segments is basically between applied research and development. But there is still something missing on this chart. And who is going to perform the task you need to be done in those 4 segments? And here is the question of capacity building, and where both of these segments, actually industry and academia, are actually can collaborate the most. So let's have a discussion about Slovakia and, for example, the space safety domain. Do we have capacities for space safety domain here in Slovakia? Basically, no. You cannot just now open a store and say, I will take a person from our market and use this person to perform space safety related services or help to develop space safety products. For that reason, it is actually up to industry and academia to together focusing on building capacities the way that we can cover all the 4 segments I mentioned before. Slovakia, which you have to all actually realize, is that we are just a very fresh member of the European Space Agency, and the whole ecosystem is just, or the whole space segment is emerging in Slovakia. So we have a lot of potential, actually, what can be done in this segment. We are associate members since October 2022. And we have a good potential for actually growing new capacities for space safety, but not only space safety, space in general. And you see on the chart on the right that all of the key, let's say, stakeholders can actually help to make it happen. So we have here academia, which is actually engaged with industrial partners, professionals. We are doing students counseling. We are doing, for example, creative thinking lessons, so we are actually encouraging creative thinking. Students, they have technical skills. They are actually extremely highly skilled individuals. And what is maybe something which is very good input from the students, which they can bring to both the segments, is they have innovative ideas. And then we have an industry. Industry can actually help to supervise the students through projects, can provide even corporate training, support and finance projects. I already tried to talk about it, and can actually show the students how they can move from academia to, let's say, the professional career. All right, and now basically you saw that in my affiliation I had 2 different institutions, so I will try to introduce you to those institutions to give you a feeling how we actually collaborate and how it's done. So first one is the Space Debris Research Group. It's actually a group which is consisting of 3 PhD students and 1 master student at the moment, with 1 PhD student, finished his PhD, I think it was the official one, first one in 2023, which was focused on space debris research. And we are also collaborating with Department of Applied Informatics, which is very crucial for us to actually also have a good connection to new, let's say, programming opportunities. And there we have also 2 PhD students who have topics related to space debris. Our research is mostly focusing on space debris characterization. That means with using our own infrastructure at the Astronomical and Geophysical Observatory. And the objective is to understand the objects, even they're known or unknown, what are the properties, what is the size, what is the surface properties, chemical composition, which might be used to actually analyze their negative effect on the space environment, on the atmosphere, but also on the ground. The main instrument we are using is the AGL-70, which is this telescope, big one in the middle. That's the main instrument we are using. The Space Debris Research Group is basically collecting data and then we are analyzing them. So we are using, for example, photometric filters. We're using spectroscopy to understand better what are the objects' origins. And we are also interested in the rotations of the objects, so the photometric footprint these objects are creating, which are helping us either to classify the object, but also to understand its rotation, for example, for future active debris removal missions, which is a direct application of such research. As a research group, we are also, our main outputs are usually publications. So here are 2 examples of publications for 2 of our PhD students. On the left is Danica Žilková. She will be finishing this year. And on the right is Maciej Zigo paper, which already finished in 2023, his PhD thesis. So this was a research group. Now I'd like to move to the industry. The second affiliation was called Astros Solutions. It was established by me in 2019, and we have headquarters at the moment at the faculty. So this is part of the collaboration we have. So we are in the F2 pavilion, having rented 2 offices. We are a team of 5 experts. Without me, it's 5 experts, where 4 of those 5 experts are graduates from this faculty. 2 of them are from Astronomy Astrophysics department or program, and 2 are from Applied Informatics program. The main focus of the company is on research and development projects in space surveillance and tracking and in space safety domain. Basically, what we do, we are developing products and services which force us actually to also do development of the hardware and software. So on the left-hand side, you see animation about capturing the real video, how we perform the observations of objects on LEO, on lowered orbit. For example, this is an example for OneWeb satellites which are placed 1,200 kilometers above the Earth's surface. Our telescopes can observe everything from lowered orbit when you have an ISS, International Space Station, up to cislunar region when we use our collaboration with Comenius University. And in the end, we have products available which are then sold. Either you sell, as I mentioned, selling the positions of the objects, which helps to improve the orbit information and conjunction analysis. And secondly, you can provide photometry data which are helping to analyze the health of the spacecraft on orbit to operators, for example. Currently, Astros Solutions has its own network of sensors. We have 3 sensors in Slovakia, 1 in Western Slovakia, in Central Slovakia, and 1 in Eastern Slovakia, so a very good triangulation available for the lower orbit and also concerning the weather constraints. And we also have 1 sensor in South Africa, which is covering the southern hemisphere in our case. It's a test bed which we are now making run as a routine system. All right, so this was the introduction to those 2 entities. And now what happens when they meet? So I will try to give you the story, how this all happened, why we are here, why we have so many PhDs, and why we have experts already available at Astros. So I will do some, let's say, chronological evolution of the events that happen actually in Slovakia, because we are strongly connected to the space environment which is happening here in Slovakia. So we are mostly focusing on collaboration between the researchers and Astros via European Space Agency research and development activities. In these activities, each partner has its own specific role, and we try to make sure that students are always involved in these activities. That means when there is activity or PhD topic, you will always should find a link between those 2. So in 2016, Slovakia signed PEC's contract with European Space Agency. This was a period of time when we were applying to become ESA member state. So ESA said, give us a contract. I said, now I will be collaborating with you. You're not ESA partner, you're not ESA member state yet, but I will rent you my managers. They will help you to bring your technology, know-how, capacities to level that you are competitive in one moment in ESA. So we already jumped on this initiative, and we took PEX 1 and PEX 3 calls, so they went one after another. There was PEX 2, we jumped for space safety in this topic of what we're doing. So we were continuously doing development in Slovakia, mostly focusing on AGL-70 telescope I showed you before, to make sure that is an example of a SST sensor. Then Astros was established in 2019 when we knew that the capacities are already available and also some of the technologies. And Astros also was awarded by own contract, which was basically the boost to make the company run. Then Astros was getting more and more successful through different calls, thanks to the team we had available. But for each topic, you might see this small icon here. For each of these activities, we always brought Comenius on board to help us to either focus on research questions or to make the students involved in the activity. In end of 2022, we become associate state, but that's not the only thing we became. We subscribed to space safety program. It means when you are associate member of ESA, you are only applicable to specific topics which are in ESA. For some of the topics, you have to have an extra subscription. And thanks to all the development done and research before and projects, Slovak government as well as European Space Agency decided that it would be the best for Slovakia to actually focus. It was not only because space debris, there was also space weather, very strong group in Košice in eastern Slovakia, and there were some promises also in planetary defense segment. And then our group was focusing also for doing some research at home with our colleagues from experimental physics, where we did analysis of light pollution. And now we are, after a successful negotiation, to move forward with characterization of space objects, where is the first time actually Comenius took Astros as a partner, which will be responsible for commercialization of this development. And then Astros was also continuing, always taking Comenius on board. So here you see another 2 calls from this year, which were awarded to Astros. But also, it was the first time in history of Slovak Republic when we also company got awarded for a full-blown activity. This is not activity for, they sometimes call it like kindergarten, because even as an associate member, you're still protected. You are not still full member. You're not still the member who has this full competition against all these big players. But this is the first call, which was open call for everybody, not only Slovak entities. And we also focused slightly on capacity building with our colleagues from Technical University in Košice. We had one study, Comenius, but also Astros, where we were having a look on curriculum of our university and our faculty to see if we can somehow adapt it the way that we can improve capacity building towards space safety expertise. Okay, and now I would like to show you example of a collaboration between Comenius and Astros Solutions. So one activity, it's called ROSY, was the one, almost the last one I was mentioning. This is the largest activity even awarded to a Slovak company in Slovakia. And her primary objective was to plan and coordinate a mission, a plane, full of instruments, which will go to specific location on Earth, and this plane with all the experts on board will observe re-entry event of one specific object. That object was a SALSA satellite from constellation Cluster. Cluster constellation was a European Space Agency mission, which was now finished their mission, and ESA now has 4 pieces which they can shoot into the atmosphere under specific conditions, and comparing to other missions we have, you can do it with accuracy of few hundred kilometers. That means you have the luxury to actually send a plane with people to observe this event, and you can even repeat this whole experiment because you have 4 satellites like this on orbit. And 2 of them will go down next year, 2025, and 1 of them 2026. So, and it was a daylight re-entry. So the object was re-entering, I will try to show it here, coming from the east, going above west of Eastern Island. Our mission was to send a plane from Eastern Island and observe this object once it was re-entering. The objective was to gather as much as possible information to understand the physics of the re-entries, which are very huge unknown at the moment, and there are models for it, and we want to refine these models, but you need to have inputs to these models. So industry, the Astros, was responsible for coordination, project management, so we were the ones actually talking to ESA, making understanding what ESA wants, and we also coordinated the whole plane mission and making sure that all instruments and experts are on board. Comenius University sent a group of experts, Jiří Šilha and Tomáš Paulech, who are responsible to actually capturing the data. Jiří Šilha was on orbit, you can see it here, not on orbit, but on board of the plane. So here is the interior of the plane, and here is the plane itself. And here is the instrument Jiří was actually installing and operating. There were 4 instruments from Comenius University. And Tomáš Paulech was responsible for the ground station, because we were very close to Eastern Island, so it was big chance that we can even observe it from ground, which will be actually giving us even more information thanks to the triangulation we could reach or get with this. So eventually we flew, and we were able to capture the objects. Please keep in mind this was a daylight, noon, it was noon, local noon, so crazy bright sky. And we were quite far from the object, roughly 800, 1,000 kilometers. So on this image on the right-hand side, you see the moon as a reference, and the same field we could capture SALSA during the re-entry. The data is now being analyzed and not too much is public, so we have like 2 frames of pictures to show, but this is just a zoom of this one. You see there is a very bright layer of clouds we had to deal with. Comenius was eventually able to capture the event with 2 cameras from 4 instruments that were available, and ESA was present on the mission and was extremely happy with the result. So which means for us, all of us, that we will most likely repeat the experiment, and we will go for another cluster mission, and there is another Draco mission coming in 2027. So we probably will have consecutive years of this type of campaigns and data collection. Another collaboration example is SATFIELD is a service developed together between Comenius and Astros. Basically, you all noticed, I've been recently in AGO, and I noticed that the Starlink OneWeb satellites are very bright, but the Starlinks were spread not only in small pearls close to each other, but you can even see them spread all over the sky in different planes, which is disrupting your field of view or point of view or when you're looking at. But this is not a problem only for humans when you try to show constellation to your girlfriend, boyfriend, or your wife or kids. But this is big problem for professional observatories, which can go even deeper. They see up to 21 magnitude. We see only to 4 to 5 magnitude. So they see these objects after sunset and before sunrise quite often. So our idea was, let's create a tool which is available to the community, where you can actually select where you're going to observe, and the tool will tell you what will be passing through your field of view. Is it a good location you want to do the observations, or it's not? And how to optimize your planning. So here's the example of a video showing you that you can choose the time of observation on the left-hand side. Then you can choose a location here where you are. We are connected to the database of Minor Planet Center. So you can just choose what is in the database. There are hundreds of observatories you can choose from, or you can just put your own coordinates when you are somewhere on the in the field. And eventually, the user can also select the specific field. So I'm an astronomer, I'm preparing my plan. I plan to be 30 minutes on specific field. And if I point there, this tool will actually tell you what's going to pass through your field of view and how the field of view will be distorted. And on the right-hand side, you can see actually QR code to the service. And now the service is a beta testing. So it means the traffic is not well organized because it's just the testing at the moment. So once the results are calculated, you see for your specific field that what will be passing through. So these large streaks are usually the lowered orbit object, and the small ones are usually the object on very high orbit, which might not be such a problem for you when you do your observations. So this tool was developed, the engine of it was developed as a master thesis topic of Adam Regan in 2024. And Astros took over the engine and is responsible for hosting this service, front end and back end. So it means making it so smooth, good looking, easy to use. What is good about this service is that you can use it also on your cell phone. It doesn't matter if it's Android, Mac OS, or Windows or Linux. It doesn't matter if it's a laptop, a PC, or mobile phone. So that's one of the examples of collaboration, and this year we also have the opportunity to publish together. So Astros was actually co-author of several different papers, technical papers, at the International Astronautical Congress in 2024, which was in Milan. On the left-hand side, you see the paper from Maciej Zigo, where Astros was the main author, and we invited Comenius, which I was representing. And then on the right-hand side, you see PhD work of Tomáš Hrobar, our PhD student, which was also collaboration with Astros Solutions, which is also affiliated there. All right, so my time is off, so I will go to the closing message. So that was the story, how we did it. Now we have 5 experts. We have still PhDs, so the research group is working as well. The industry is working, and we both are actually quite successful with ESA projects. So what's the way forward? I would like to emphasize that we should continue collaborating. Everybody has this, of course, opportunity to reach out to industry because industry can bring something on the table. And when we actually overlap quite the most is applied research, which might be the meeting point, development. But I think one of the key elements why I came here to Slovakia from Switzerland was the capacity building. The potential actually to bring new people, new ideas, and to create something like a space ecosystem for space safety in Slovakia. And with that, I thank you very much for your attention.